David Smith here with another Flip Classroom video. 3 tips before we start. First, remember you can pause the video anytime to catch up with your notes. Second, you can turn on the captions below so you can watch my words go by on the screen. And lastly, you can play the video at double speed if that helps you get through it faster. Today's lesson covers horizontal and vertical lines. And these are special lines that have simpler equations. They're actually, once you get it, they're actually easier lines to deal with. So let's take a look at a horizontal line first. Here's my graph with my x and my y axis. And as you'd expect, I've drawn a horizontal line here and it's horizontal. It doesn't have a slope that goes up or down. So the slope is 0. For a horizontal line, we already talked about that earlier. I have a slope of 0 because I don't have any rise. I only have run. Okay, so horizontal lines have the form y equals c, some constant. It's going to be a number out there. Now you notice how the equation doesn't have an x, and that's because the horizontal line doesn't depend on x. It just depends on what that constant is. So take a look at this graph, pause the video and do some thinking. Can you tell me what this line is going to be? It's y equals something, but what is it going to be? Okay, let's see how you did. Check this out. 1, 2, 3. No matter what x is, y is 3. Okay, so when x is 1, y is 3. When x is 3, y is 3. When x is a billion, way down there in the next state, y is still 3. So for a horizontal line, it doesn't matter what x is, y is always something, in this case, 3. Now check it out. If I were to draw one down here along this path, what is y? Pause the video, think about that, come up with a number for what this line equation is. Okay, if you said y equals -2, you're right, because no matter what x is, y is going to be -2. We're down below the x-axis. Okay, let's look at vertical lines. Very similar to horizontal, only instead of flat, the line is completely vertical. Now, as you remember from our slope lesson, we talked about slopes of vertical lines. The slopes are undefined. That's because we have no run. So on the bottom of our fraction rise over run, we have a 0, and we can't divide by 0. Mathematics is sort of broken for division by 0, so we call it undefined. So a vertical line has an undefined slope. Now, the equation of a vertical line is always x equals a. We're just using a different letter, but we mean the same thing. It's some constant, some number that never changes. So a vertical line, y doesn't matter. It's completely determined by what x is. So now I want you to pause the video, think about this graph. I have my vertical line right there. Think about this graph. What is x going to equal on that graph? Okay, let's see how you did. Check it out. 1, 2, 3, 4. X equals 4. Doesn't matter what y is. When y is -2 down here, x 4. When y is 1, x is 4. When y is a gazillion billion way up in the next galaxy, x is still 4. So a vertical line doesn't depend on y, and notice how there's no y in the equation for our vertical line. So now I'm going to give you another one. Tell me about that one. What's the equation for that one? Pause the video, put on your thinking cap. Okay, if you said x equals -3, you're right, because we're 1, 2, 3. So everywhere on this line, the x value is -3, and that's another vertical line. Okay, here's an interesting variation on a kind of question that you might get on the exercises in this unit. Let's put my units on my graph. So here we go. Find a, remember that's that constant for a vertical line. Find a such that a7 lies on the line x equals -2. Okay, so to answer this one, I'm going to throw x equals -2 on the graph. So we go 2 negative. This line goes right there. This is the line x equals -2. Okay, so now a is the x coordinate. What is a when y is 7? So 1, 2, 3, 4, 5, 6, 7 really doesn't matter because wherever I am, a is going to be -2. Remember, the x value on a vertical line is always the same. It's the value given by the equation. So in this case, a equals -2. Now, if you understand how this works, you don't need to make the graph. You know from this equation that every point on this line has -2 for the x value, or in this case for the a in that equation. Okay, here we go. Where do the lines y equals 3 and x equals -1 intersect, which means where do they cross? Now, if you understand this question, this is a quick critical thinking step. You could just write the coordinates. I want the coordinate points of this intersection, but I want to graph it just to show you so you can see how straightforward it is. So there's our x-axis and our y-axis. Let's put some tick marks on there. So check it out. Y equals 3. That line goes right through here. This is the line y equals 3. And then the line x equals -1 is 1 to the left. So that line goes right through there. That's the line x equals -1. They intersect right here. Now what's that point? That point is -1, 3. So the answer is -1, 3. So if you get this question again, you're just going to see that's the x value of the intersection and that's the y value, because they intersect right at the points listed by their equations. I forget how I start that. Does it go?
Here, I can
That's all
hope the
for
video was
today.
helpful. I can
What?
put it.
Now that you've watched the video, write down any questions you still have so you can remember to ask them in class next time we meet. Also note that you can watch the video again if you want to deepen your understanding or patch up any gaps. Finally, give me a like and subscribe if you enjoyed it.
Yeah!